In this next section, we are going to be talking about the slope. The slope of a straight line. The change in the y values is the vertical change, or sometimes called rise. The change in the x values is the horizontal change, or the run. And m is what we commonly use to denote the slope of a line. The slope of a line is related to its steepness. So in other words, it's a measurement for how steep a line is. Positive slopes, the line rises from left to right. Negative slopes, the line falls from left to right. Let's have a quick look at a picture. So if I have my coordinate system here, I'm saying this is the y-axis, this is the x-axis, and I just let 2 points, without knowing what the values are, I'm going to say this one right here is the x1 coordinate, this is the y1 coordinate, so I have a point right here, and the coordinate of this point now will be, well, it will be x1, y1. And I am looking at a second point whose x-coordinate is here and whose y-coordinate is there, so that will be approximately here. And the coordinate now of this point will be, well, x2, y2. So if I'm now drawing a straight line that goes through these 2 points, then my line would roughly look like this. And let's make a little picture. So from this point down here to this point, something changed. The y-coordinate changed. This right here is the distance between these 2 y-coordinates. Well, how do I calculate this? This distance right here is the long piece minus the short piece. So in other words, y2 minus y1, which we also call sometimes rise. Now from this point to this point here again, there is also a change happening in the x-coordinates, which is this distance right here. And this distance right there, we are going to calculate similar to the one before. The big chunk minus the small chunk, that would be x2 minus x1. This is how long this is, how far away these 2 points are from each other. And this is sometimes called the run. All right, so if the slope of a line through 2 distinct points, x1, y1 and x2, y2 is m, then we can calculate m by saying, all right, this is the change in your y value divided by the change in your x value. And the formula would be y2 minus y1 is equal to x2 minus x1. Using this formula right here, we just have to be careful that the points stick right on top of each other and that they don't mix. It does not really matter which point you will call x1, y1. That does not matter. Just be careful that this negative sign inside right here does not belong to the coordinates. I'm going to show you another way how to calculate the slope in a much easier way, I hope. So here's another way how you can memorize this. This is more what we use in our science classes. The change in y, change delta y divided by the change in x, delta y over delta x. So let's go ahead and find the slope. We want to find the slope of the line passing through the following 2 points, -7, -8, and 4, -2. So which one I'm going to call x1, y1, it doesn't really matter. Let's say I'm going to say x1, y1 is the first point, -7, -8, and x2, y2 is the second point, 4, negative 2. Then m was equal to y2 minus y1 divided by x2 minus x1, which will give us now, here's a good idea, put parentheses first and then substitute the coordinates in. So let's have a look. y2, what was y2? Where was y2? Right here, negative 2. Minus y1, where is y1? Right there, negative 8. Now on the bottom, x2. What is x2? x2 is positive 4. And x1 was negative 7. So this right here now, I'm going to calculate out. Let's have a look. We are getting negative 2. The negative of a negative 8 is a positive 8. Divided by 4, the negative of a negative 7 is a positive 7. And that will give me a negative 2 plus 8, that will be positive 6. Divided by 4 plus 7, that would be positive 11. And I have my slope. Now this means now two things. The slope is positive. Well, one thing. The slope is positive. It would always be a good idea to check your answer really, really quickly. It doesn't have to be very pretty and very accurate, just a quick sketch. Plot your 2 points in a coordinate system. Y, x. All right, negative 7, negative 8. Where could this point be? Let's have a look. Negative 7 means it goes to the left. Maybe here. Negative 8, it means it goes down. Let's say down here. This is the point. Let me say negative 7, negative 8. Where's my second point? 4, negative 2. 4 means I had to go to the right, and negative 2 meant I had to go down a little bit. So maybe like this. 4, negative 2. This is my second point. Now I'm looking, and when I would sketch my line, I believe now that I have found the right answer, because this is a line that rises from left to right. It should have a positive slope. All right, let's do another one. Oh, one more. Possibilities for a line's slope before we calculate more slopes. What possibilities do we have? Well, coordinate systems, really, really sketched and quickly. A positive slope goes up, could look like this. A negative slope goes down, could look like this. What is the slope of a line? 0. Well, it doesn't go up, it doesn't go down. That will be a horizontal line. There is no change in your y value. The change in y is 0. What do we have for undefined slopes? Well, that would be a vertical line, because at that moment the change in x is 0. And remember, delta y over delta x, this down here, cannot be 0. So if the change in x is 0, then that is undefined. Let's go ahead and find the slope of the line passing through 4, negative 2 and negative 1, 5. This time I'm going to show you this in two different ways. Let's first use our formula. M is equal to y2 minus y1 divided by x2 minus x1. Let's have a look. y2, let's say y2 is 5 and y1 is negative 2. Then I will get (5) minus a negative 2 divided by negative 1 minus positive 4. And that will be 5 plus 2 divided by negative 1 minus 4. And that will be 7 divided by negative 5, or negative 7/5. All right. Another way. I like this way actually personally more. If I have a point and I have a second point and I'm trying now to find the slope, let's say this is method 2. I'm trying to find the slope from the first point to the second point. Then I'm just remembering this. The slope, m, is the change in y over the change in x. Alright, so if I'm just focusing first on my y values, the change from -2 to +5. Well, how much is that of a change? From -2, how do I get to +5? By adding 7. And the change in x was from 4 to -1. So from 4 back to 0, that would be -4. Go 1 further, that would be a -5. And look, I'm staring at my slope. +7 divided by +5. Let's make that 5 a little bit better. All right, let's have a look at another one. Find the slope of the line passing through 6,5 and 2,5, or state that the slope is undefined. So, I'm looking at my 2 points, 6,5 and 2,5, and I immediately notice something. The thing that I notice is that the y-coordinate in both cases is the same. So, I have now again 2 possibilities. I could use my formula. M is equal to y2 minus y1 divided by x2 minus x1. I could substitute my values in. 5 minus 5 divided by 2 minus 6. And what will I get? Well, I will get 5 minus 5 divided by 2 minus 6, which is 0, divided by -4, which is 0. Good, that is one way. But another way, of course, would be to notice what we have noticed at the very beginning of this problem, that the y-coordinates were the same. So, in other words, how do my 2 points look? Well, 6,5, let's say 6,5 is right here, and 2,5 is right here. Well, these 2 points lie directly next to each other. They are lying on a horizontal line. And a horizontal line has slope 0. So that method right here, if we want to call this method 2, and this one method 1, would be a little bit faster. Let's have a second, and let's have another one. Find the slope of the line passing through 1,6 and 1,4. Or state that the slope is undefined. Well, you might notice immediately something, that in this case there is something the same again, and the thing that is the same is the x-coordinate. So let me use method 2 immediately. These 2 points would lie inside a coordinate system how related to each other. If this is 1 and that is 6, then 1 point is up here, the first one, and the second point would be, let's say, down there is 4, 1,4. These 2 points lie directly above each other. So what is the change in your x-coordinate? It is 0. And delta y over delta x, this can't be 0. So the slope is undefined. Slope is undefined. If I would have used my formula, m is equal to 4 minus 6 divided by 1 minus 1, I will get 4 minus 6 is a -2 divided by 1 minus 1 is 0. No, this can't happen. We cannot divide by 0.